What's up, you guys? Let's talk about pandas. And by pandas, I don't mean those cute animals that are black and white. No, I mean the Python package that is fast, flexible, and expressive when working with data structures that are designed to make working with structured data both easy and intuitive. So, pandas is a package like any other package, like NumPy, Skippy, and so on. But the main use of pandas is when you have big data that follow a certain structure, such as tables or multidimensional arrays. When you have, let's say, a big spreadsheet with a lot of worksheets in it, you would like to extract them in a very fast and flexible way, then pandas is the way to go. And when you're potentially dealing with heterogeneous data. It is also used when you have time series. For example, when you're watching the stocks, you would like to extract a stocks from a certain API or a certain data source. So Pandas is a really good way to both process the data and visualize the data. It also aims to be the fundamental high-level building block for doing practical, real-world data analysis in Python. In addition, it has the broad goal of becoming the most powerful and flexible open source data analysis available in the open source world. It is already well on its way towards this goal. Now, Pandas is well suited for many different kinds of applications and data. So, for instance, when you have tabular data with, let's say, possibly heterogeneous typed columns, as the case in SQL tables or Excel spreadsheets and so on. When you also have ordered and unordered time series data, so for example, when you're dealing with stocks. When you have arbitrary matrix data with rows and columns, and could be labeled rows and labeled columns, so it's not necessarily that your rows and columns are indexed by numbers. No, they could be indexed by dates or closing price or whatever data there is. So it doesn't have to be numbers. And that's what makes Pandas really special. So the two primary data structures of Pandas are series and data frames. So series could be seen as a one-dimensional array. It's a data structure which is one-dimensional, as simple as that. And the data frame is two-dimensional. It could be seen as a stacking or a composition of series. It is handled with a vast majority of typical use cases such as in finance or statistics, social science, and many, many other areas in engineering. Now, why do you want to use Pandas? Pandas is easy to use when you have missing data. Let's say you have an Excel spreadsheet which doesn't have a full matrix form. Let's say some entries in the spreadsheet are missing. So Pandas provides you with some methods that allows you to easily deal with those missing data. It's also intelligent when you have labeled data for large data sets. It's also an excellent choice when you want to merge or join data sets in a certain way. We'll see how this is done later on in the course. When you also have some hierarchical labeling of axes. So let's say you have, I don't know, on your rows of the spreadsheet, you have countries, and within each country you have specified attributes. And this follows a hierarchical structure. So Pandas helps you deal with those structures. It is also a good choice when we deal with time series, and it has some specific functionalities for that, such as data range generation and frequency conversions. You also have moving window statistics, such as moving average or autoregressions, or both autoregression, moving average, and so on. So if you're familiar with finance or statistics and you would like to use well-known models such as those I mentioned, then you do have those functions within Pandas. You've also got stuff like data shifting and lagging and so on. Pandas also provides you functionalities such as reading and writing from spreadsheets, reading and writing from text files, JSONs, and HTML. You could read and write over the web, which is a pretty cool thing. Now, we're not going to discuss how to write on the web because that's basically not what we're doing. We're not going to send. We're not the aim of Pandas is not to talk or send data to some sort of API. No, it's basically receiving data. So let's say you'd like to receive some sort of table or some sort of tabular data structure from a certain API or from a certain website. Well, you can do so easily using Pandas. And we'll see how to do that within the course. So this is it for the introduction of Pandas and what is Pandas. Let's get started with how to install Pandas on our machine. So in case you're wondering why I have my terminal open in my browser, well, I'm going to be using Jupyter. So Jupyter is a really flexible editor which allows you to type code and observe the output right under the code. So it's really like Mathematica. In case you've worked with Mathematica or Wolfram, well, it follows the same structures, the same graphical user interface. So if you don't have Jupyter on your machine, it's okay. You can use any editor you want. I'm going to use Jupyter. So the way to install Jupyter is as simple as that. pip3 install Jupyter. Now I have it already on my machine, so I'm going to be greeted with those messages, requirement already satisfied. In case you don't have it, you'd have to wait a bit depending on your connection. Now, to get Pandas on your computer, all you have to do is type in pip3 install or pip, depending on the version of your Python, install Pandas. Again, since I have it, I will be greeted with this message, which is requirement already satisfied. In case you don't have it, it also requires a bit of time to install. We will also be using NumPy a bit. So pip3 install NumPy. I already have it, as you can see. And that would be it. Now, in case you're using Jupyter, you'd have to navigate through a certain path, a certain directory that you will be working with. So I'm going to navigate through the following directory. So right now I'm in this directory, which has only one folder called data files, which I will be using to read some spreadsheets from, or CSV files. Okay. In case you don't have spreadsheets or any, just create them from scratch. You just open Excel and create a random spreadsheet. Okay. I have the following spreadsheets. So I've got a McDonald's CSV, Walmart stocks, some stock CSV files. You can just download a random stock file or a CSV file from the web. It's not a problem. So to get Jupyter working, all you have to do is type in Jupyter notebook as such, and the browser will, initialize Jupyter for you, and it will show you the contents of your folder, which in my case is learning Pandas. So right here, create a new Python file, and over here you could, name the file. We'll call it main, rename. And do not close your terminal in case you're using Jupyter. If you do, then this compiler will not run. So you cannot execute code as such when this instance of the terminal is closed. This is actually where the process where Jupyter is running, okay? So if you want, just minimize it as I will do right now. So let's start by importing the modules we will be working with. So Pandas as PD, and I will also need a NumPy. as empty. Hit Shift Enter, and all is good. So let's start with series. So the first thing I would want to discuss is series. So I'll set that as a markdown, Shift Enter. So the first block we will talk about is series, because it is really so data frame is the essential data structure of Pandas, and series could be seen as one column or one row of a data frame. Okay? So series are similar to NumPy arrays or lists, except that we can give them a name or date time index. So let me show you what I mean. Let's say I've got a list as such, 1, 2, 3, right? This is a list. It could be indexed by the index number. So list 0 is 1, list 1 is 2, and so on, right? So on the other hand, series could be thought of as a dictionary. So let's see how to initialize a series. Let's say I want my indices to be letters A, B, and C as such. And I want my data to be 10, 20, and 30. Okay? Now, the way you would initialize a series is, let's say series 1 or S1 is pd.series. The first index is your data, and the second one is the indices as such. Hit Shift Enter, and all is good. Now, you want to see what S1 contains, just type in the following, and you can see the following. So the first column is actually the index column. So to extract 20, you need an index of B. To extract 10, you need an index of A, and so on. So let me show you what I mean. S1 of A is 10, S1 of B is 20, and S1 of C is 30. Okay? And you can achieve the same thing by passing a dictionary instead of 2 arguments right here. So let's say you've got a dictionary, or you'd like to, I don't know, initialize your series using a dictionary. Well, you can do this, pd.series, and right here, all you have to do is enter a dictionary. So A is the index or the key, and the value comes after, B 20, and C 30 as such. And I would like to print it as well, and there we have it. Okay? So as we mentioned earlier, we could access elements in a series as such. We could modify elements. So S2A, I don't want it to be 10, I want it to be 10 to the power 3, for example. Let's see what S2 is, and we have 1000 instead of 10, which is 10 to the power 3. You could also add to series. So S1 plus S2 is the following. So we had S1 as such and S2 as such. So what happens is that the same indices are, the values sitting at the same indices will be added to each other. So 10 plus 1000 is 1010, 20 plus 20 is 40, and 30 plus 30 is 60. Now what happens if I have different indices? So let's say I have another series which has A holding the value 50 and only D. So we don't have B and we don't have C. So D holds a value of, let's say, 70, right? So let's say I want to add S1 with S3. What would I get? Let's check it out. S1 plus S3 is the following. So the value of A would be added to the value of A right here, which is 60. The value of B would be added with nothing here, which is NaN, or not a number. The value of C, which is 30, will be added to a value of C right here, which does not exist, and again we get an NaN. And the value of D right here will be added with nothing, and again an NaN. So if there is no common index, the output is not a number, or NaN. Okay? Now, of course, we could add series, we could also, subtract series as such. We could multiply series, right? It's pointwise multiplication. Can we divide? Yes, we can. Also, let's say you'd like to compute the sum of your series, S1. So you'd like to return 60, 30 plus 20 plus 10. All you have to do is S1 dot sum as such, and there you go. You could also return the product of the entries as such, and there you have it. So that's it for series. Let's now talk about data frames. Make it as a markdown, and there you go. So what are data frames? They're just two-dimensional, size-mutable, and potentially heterogeneous tabular data structures with labeled axes. Means that you have your rows and columns being labeled. So as we saw in the series right here, our indices are labeled. Well, those indices will serve as indices for columns and rows in data frames. You could also perform arithmetic operations to align both rows and column labels in data frames. You could think of data frames as dictionary-like containers for series objects. So in other words, they are just a concatenation of series right next to each other or one on top of the other. Okay? It is the primary pandas data structure. So when you talk about pandas, the first thing that should pop in your head is data frames. So pandas makes it really easy to work with data frames because it is a data structure within pandas. You could easily define a data frame as follows. So let's say I have a data frame called df. So df dot is equal to pd pandas dot data frame. And right here, you can input a whole lot of arguments. So to read more about this object, all you have to do is hit Shift and Tab and plus right here. So what we have here is that it's saying it's a two-dimensional size mutable, potentially heterogeneous tabular data structure with labeled axes. We just discussed that right here. We just talked about this right here. Now, I'm concerned with the inputs. So what are the inputs here? So you have the data, which is in the form of a matrix, right? Two-dimensional data right here, with the indices of the rows and columns right here. So index means the index of the rows, and columns refers to the index of the columns. You also got D type, which is optional in case you want to specify the data type of each entry. We will not be using this. And you also have the copy argument, which if you want to know what it does, it's written right here. So it's a Boolean. It's either true or false. It just copies data from inputs. Only affects data frame with 2D and D array inputs. Means that when you're working with 2D and D arrays. Okay? Now, let's define our first data frame. So let's say my data, I would like to have some random data. I would like to generate it from the NumPy library. You can generate it from any other library or by any predefined data. So np random.rand. Let's say I want data to be 3 by 5. I want 3 rows and 5 columns, which means that over here I have to specify 3 indices. So let's say uppercase A, uppercase B, and uppercase C. And in the columns, let's specify 5 column indices. Let's call them, I don't know, price, volume, return rate, open price and close price, right? So if you're familiar with stocks, those should be common terms. They should be familiar. So hit Shift Enter and you have your data frame set. So let's see what's inside my data frame. And there you have it. 3 rows, 5 columns. The rows are indexed by ABC. The columns are indexed by the indices right here. And the data are random. Okay? So how do I extract a certain column from a data frame? It's as simple as that. df and just mention the attribute or the index. So let's say I want the first column, which is indexed by price. All I have to do is mention price. There you have it. Now, what is the return type? That's important. The return type, if I type df as such, only df, of course, I should be able to see data frame. It's a data frame, of course. But what happens if I extract a certain column from the data frame? It's a series. And that is why we said it's a two-dimensional series. It's just series stacked next to each other or one on top of each other. Now, each column is a series. What about each row? So how do I extract a row? You cannot just say df a as such. You will get an error which tells you that duplicate columns and possible reduced dimensionality. Okay, that's not really informative. But you cannot index rows the same way you index columns. To index a row, you would have to use .loc or location. And right here, you could extract a certain row as such. Now, what is the type of this row? It should also be a series. So rows are series and columns are series. This means that all the operations we mentioned previously, right here, could be used. Okay? Now, going back to this notation right here, how do I read any entry? Well, all I have to do is first specify the column name. Say I would like to extract 0.058233. It's found in the volume column and the row C, indexed by C, as such. There you have it. Okay? And how would you extract it using the loc or location command? Well, you could treat it as a matrix. So in matrices, we know that we index a column or we index a certain entry by first mentioning the row, then the column. So as the opposite of this notation right here, loc works as such. C.loc volume. As such. Now, if you prefer matrices or you've worked with MATLAB before or Mathematica or whatever, and you worked directly with matrices, you would prefer maybe this command over this command, because this command right here is columns then rows, whereas this one is row then column. Okay? You could also, in data frames, you have some sort of multidimensional higher indexing. So let me show you what I mean. Let's say you would like to have 2 layers on your rows. So you don't want only a 1-dimensional row, you would like 2-dimensional rows. So let me show you what I mean. Let's say I have on the outside a country which is Lebanon and Lebanon. Then I have France, then France, and possibly USA, and USA. Okay, this is on the outside. And on the inside, not in, I should be using in, sorry, inside as such, I've got those indices, A, B, C, could be morning, evening, midday, and evening. And let me replicate those 3 times. Of course, you could do this using a loop, but I'm just trying to show what multidimensional indexing is using pandas. So let's create now a data frame, which is dd.dataframe. And right here, I will have 1, 2, 3, 6, 9 rows, right? So np.random .rand 9 by, let's say, 3 columns. And here I should have some sort of index, which I didn't define yet, index for the rows. Of course, it's a combination of outside and inside, right? And on the columns, I should have something like anything like price, close, and open, for example. Now, index should be generated using out and in. It is going to serve as the index for my rows. So index rows, and let's set it here. So index rows is a zip of outside with, or out, it's called out with inside, right? And now let's convert it to a multi-index object. So conversion goes here, pd.multi-index.from tuples, because we have a tuple right here. And let's pass it index rows for conversion, right? So I'm ready to run this block of code, and there you have it. So as you can see, we have multi-indexing on the rows. Lebanon has morning, midday, evening. France has morning, midday, and evening, and USA has the same. And all 3 share the same columns, same attributes of the columns, right? So how does indexing work here? Well, it's the same as we mentioned previously. All you have to do is, let's say, .lock. First, you mentioned the outer index, which is, let's say I would like to see what's going on in Lebanon on the evening. I would like the closing price, which is 0.22, okay? How do I extract that? So we first start with the rows, leb.lock. Now the second index, whether you want morning, midday, evening, let's say I want the evening, and then the column index, so the closing price, close, and there you have it, okay? So remember, row, you start with the row when you're using lock, out, then in, then column, okay? Using lock right here will make it much easier, so out, then in, then column, okay? So that's basically it on how to create multi-index data frames. You could also go further and create 3-dimensional indexing, 4-dimensional indexing using the same process. So you would have here out, in, and another in, so in 2. Right here you would have out, in, and in 2. And that's basically it. Okay? So now let's talk about operations. Operations done on data frames. So what type of operations can we do? Let's start off with the Boolean operations or logical operations. So right here, 3.1, Boolean or logical operations, right? So I've got this data frame called df. I've got all those values right here. Let's say I'm interested with the values that are just greater than 0.5. How do I extract values? that are greater than 0.5? Well, first of all, you would want to know the positions of those values. So df greater than 0.5 would return another data frame which contains booleans as entries indicating true at the positions where df is actually greater than 0.5 and false otherwise. Okay? Now, let's say you're interested in grabbing those entries. All you have to do is say, I want df where df is greater than 0.5. So it will return the values that are greater than 0.5 and NaN for the values that are less than 0.5. Okay? You can also go ahead and have composite Boolean expressions, such as let's say you're interested in the values that are less than 0.2 and greater than 0.9. Okay? That are less than, 0.3 and greater than 0.9. So how do you do that? Start with those parentheses, then df less than 0.3. You have to mention and, no, not and, because oh yeah, you would want and df greater than 0.9. As you can see, we have all false. And why is that? It's because a number cannot be less than 0.3 and greater than 0.9 at the same time. So this one should be an OR, right? So this vertical line stands for an OR. There you have it. So true right here, it is less than 0.3. False, it is not less than 0.3 and greater than 0.9, and so on. Okay? Now, if you would like values between 0.3 and 0.9, here is where you would use an AND. So greater than 0.3 and less than 0.9 is the complement of this data frame right here, right? So let's say you want to see the values. All you have to do is df, then the statement. And there you have it. All those values that are not NaN are between 0.3 and 0.9. Okay? Now this is everything for Boolean operations. You can make those statements as complicated as you wish. Let's say you have multiple statements you're testing. This will grow in complexity. It will grow in statements, in statement size. Okay? So now let's talk about grouping elements. So grouping elements, or also known as aggregate functions, right? So grouping elements is a way of grouping your data according to a certain metric, or known as aggregate function. So let me show you what I mean. Let's say I have a data composed of the following. So I have a data which is a dictionary, because I would like to create, so let me call this dictionary. Dictionary is a certain dictionary, right? Which is empty, and I would like to create a data frame df which is formed from this dictionary. Okay? Now right here it's going to be empty because the dictionary is empty. So let's say I have a dictionary as follows. So you should remember that each element of the dictionary is stacked in each column of the data frame. So let's say I have a country as the first column index, and right here I have Beirut or Lebanon, because Beirut is not a country. So Lebanon, then I have France, then I have Uruguay, then I might have something like I don't know, Nigeria. Okay. Nigeria as such. So this will serve as my first, column in the data frame. Now, what about the second column? Let's say I want the second column to be stock price, right? So stock price. Let's set some integers right here because we didn't work with a mix of integers and strings. 31, 321. I'll just input some random numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So let me be consistent right here and have 2 of each country. So 2, 4, 6, and then 8. Run, and there we have a data frame consisting of 2 columns. Okay? Now, since I did not specify how the row is going to be indexed, it's going to generate it by default using numbers, because I didn't mention how my rows are going to be indexed. In case you want to mention how your rows want to be indexed, so let's input here some random, letters A, B, C, D, E, F, G, and H. D, E, F, G, and then H. Okay, in case you want an indexed row. But let's keep it simple and let me just keep them numbered. Okay, so I've got this data frame and I would like to, group them according to some certain criterion. So first of all, the first useful method right here is the describe method. So describe my data frame. It will return the following data frame, which has a better description of the data frame you already have. So what does it tell us? It tells us that the stock price. Now look what happened. We have 2 columns right here, right? We have first one, the country, which is a string, and the second one is a stock price. So describe, what it does is that it computes the following metrics: the count, mean, and so on. And as you can see, Pandas is smart enough to realize that a mean of strings is not, logical, or a standard deviation of strings doesn't exist, right? So it's going to just compute those metrics for numbers. So if I had one more column right here, so let's say this column is sales, and let me just input some other random numbers as such. So I have now 3 columns, and describe should have now 2 columns. Now what does the count mean? Well, it means that you have 8 elements. Their mean, the stock price mean, is 122, the standard deviation is 128, the minimum is 12, maximum is 321, 50% percentile lies under 74.5, and so forth. Now let's say you would like to extract some of those elements. Well, you only have to treat it as a normal data frame. So with that being said, log, let's say you would like the min of the sales, which is 312, run, and there you go. Okay, now going back to describe, this is not really useful when you want to group elements. So let me show you what I mean. Let's say you would like to group by the country, because you have some common countries right here. So you would, like to compute those metrics for specific countries or as a summary for the countries. Because let's say you do not want the mean of all the stock prices. No, you're interested with the mean of, let's say, Lebanon or Uruguay. I don't know. So all you have to do is mention a group by of country, which is an object, and you cannot display it because you still have to, say what you want to do. So let's say you'd like to describe it first of all. Describe. And there you have this table. So let's say you prefer a tall table and not a fat table. So just mention .t. It will transpose the table. So as you can see here, France has a count of 2, of course, because you have 2 elements right here for France, 2 for Lebanon, 2 for Uruguay, and 2 for Nigeria. Let's say I have 1 more for Lebanon. So I'm going to add LEB right here and add 1 more element right here and right here. So run this and run that. There you have it. 3 counts for Lebanon. The mean of all values of Lebanon is this. Standard deviation is this. And so on. So each column is a description of the, the column index in this data frame. Okay? So those properties right here, those values right here, only are concerned with the first 3 entries. In other words, we're grouping according to country. Okay? Now with that being said, after you take a look at the describe method, after you take a look at the describe data frame, everything else becomes easier because you can now, say group by country, extract some useful metrics. So let's say you would like to group by company, but you would like to extract the mean only. There you have it. So the mean of stock prices in Lebanon is 121 point this. The mean of stock prices in France is 12.5. The mean of the sales in France is 162, and so on. You could also group by standard deviation. As such, you could group by the min, the max, and there you have it. So how is this read? This is my DF. The max of stock prices in France is 13. Well, let's verify. And yes, it's 13. The max of stock prices of Lebanon is 321. There you have it. The one in Nigeria is 320. There you go. And 130 for Uruguay. The same applies for sales. So that's really it on how to group or aggregate data in data frames. So those are all called aggregate functions. You're grouping by a certain index. Okay? So that's it for grouping. Let's talk about something else called concatenation. How to concatenate effectively data in data frames. So let's say I've got those 3 data frames, df1, df2, df3. Hit Shift Enter, and df1 looks like this, 2 looks like this, and 3 looks like this. So let's say you would want to concatenate df1 on top of df2 and df2 on top of df3 into one big data frame df. So all you have to do is call pd.concat, which stands for concatenate, and pass in the data frames you would like to concatenate on top of each other. So df1 is on top of df2 and df2 is on top of df3. So run this and print df out, and there you have it. Okay, so the first 4 elements correspond to df1, second 4 elements correspond to df2, and the last 4 elements correspond to df3. Now let's say your data frames are not compatible. It means one data frame has an extra column. Let's call it D as such, and it contains the values 1, 1, 1, and 1, or -1. Okay? What happens if I concatenate those on top of each other? So I will have a warning. So future warning, sorting because non-concatenation axis is not aligned. Okay? So df will look like this. It's not an error, it's a warning. So ABCs are good, as we saw, and D has not a number, an NaN, onto the first and last data frame, whereas the second data frame has -1. Okay? So this is what happens. Now, this is a concatenation, one column on top of each other. Now, what if I would like to concatenate the rows, one row on top of, according to the row axis? So first, let me go back and reset df2 as it was, as such. And let's say I do not want this concatenation, so I have to precise the axis. Now, axis is by default 0, which means along the column axis. So if you set it to 1, you will have the following. So you're concatenating data frames next to each other. So this is df1, right? This is df2, and this is df3. So the axis tells you if you want to concatenate your data frames next to each other or on top of each other. Okay? Let's hop to the next topic, which is merging. So merging is what it is. It's when you want to merge or join two data frames. Now, the difference between concatenation and merging is that concatenation will be redundant. So let's say you have two similar columns, okay, and you do not want to be redundant, so merging is the way to go. So let me show you what I mean. Let's say I have two data frames. D1 is pt.dataframe, and let me just copy paste something from here. So let me call this as my D1, right? So A, B, and C. And let's say I have another data frame, D2, which contains D or C, D, and E, right? And let's put this as common right here. So C is common, whereas the other ones are not common. So what will merge give us? Merge D1 with D2, and there you have it. C will be common. Let's say I ran concatenate. So concatenate as such. No, I would want it along the other axis. Okay, so as you can see, C is redundant. Okay, let's say I have all my attributes being common. What will merge, or what will merge give us? pd.merge df1 with df2. Now, note that df1 and df2 look like this. This is df1 and this is df2. df1 and df2 have A, B, and C common. Okay? So what will the merging give us? Merge, or pd.merge df1 with df2, it should be empty. Okay? So when do you want to use merge? It's when you have a common or multiple common columns which are shared across data frames. So merging is the way to go if you do not want redundancy. Or if you want redundancy, you can go ahead and use the concatenate method. Okay? Now let's talk about something else, which is unique values. So unique values is a way to extract unique values from a data frame. Let's say I have the following data frame. df is pp.dataframe. I have the first column, which consists of numbers as such. I have the second column, which is the following. So 31, 32, 33, and again 31. And let me put those as random. And as you can see, 31 is common. Is common across column 2. And one more column, which is or which stands for some random strings. Let's go ahead and display my data frame. It says such. And let's say I want to extract the unique elements across column 2. So let's index column 2 first of all, which is a series. And I have an error. It's 2, not column 2. So column 2 is a series, and the way to, extract the unique elements is by using the unique method of the series as such. So 31 being mentioned once, and the other elements, okay? Let's say I have 31 across all column 2, then I will have 31 being mentioned once. And what is the return type? It's an array. So you can work with it as a normal array, okay? So the first index will be this, and the second index will be that, and so on. Now let's say you would want the number of unique elements. All you have to do is mention the row as such, or the column, and n unique, so which means the number of unique elements, it's 3. You've also got value counts, which tells you the number of elements of the values. So 31 is being mentioned twice, whereas the other ones are mentioned once. And what is the type of value counts? It's a series. The way to check it is by typing in type, which is a series. Okay? So that's how you extract unique elements or information related to redundant or unique elements, right? Let's hop to the next topic, which is functions. Applying functions to your data frame. So let's say you have a function written by yourself called multiplier. Just multiplies your value or your input with a certain number, let's say times 3. Okay, so multiplier, let's call it multiply by 3. So now multiply by 3, let's pass it 5, I'll get 15. Okay, you can go ahead and pass it your data frame as such, multiply by 3, your data frame, and you will get this. So df is initially this, and once you multiply it by 3, you will get this. Now as you can see, the numbers are being multiplied by 3, whereas the string is being repeated 3 times, being concatenated on top of each other 3 times. Let's say you pass it a column. Say 1, first column, you get this. 2, you get this, and 3, the concatenation of strings, right? This is one way of passing a function to passing a data frame to a function. Now you have the other way of doing it using the apply method of data frames, and just mention the name of your function. Multiply by 3, and there you have it. Okay, you could also apply lambda expressions. So lambda expressions are anonymous functions, right? You could go ahead and say, well, I have my data frame. I would like to apply a certain lambda expression. So just square the elements and add 1. We have an error, and what is the error? Strings. We have the third column being a string. So let's pass it just one column, right? Because we cannot square, strings. And there you have it. Column 2, there you have it, and column 3 will give you an error. Okay? So that's it for functions. Let's go on to the next topic, which is removing rows and columns. Mark it as a markdown, hit Shift and Enter. There we go. So let's say you have this data frame right here, and you would like to remove or drop a certain row or column. Well, the way of doing so is using the method called drop. So let's say you would like to, drop the second row right here. Just mention the number 2, and it will be dropped. Okay. Now, let's say you do not want to drop a certain row, you would like to drop a certain column instead. All you have to do is just say along the column axis, or axis equal to 1, which means it will remove the column. Now, pay attention, the columns are strings right here. We have initialized them to be strings, so 2 will not work because 2 is an integer. So you should mention the string 2, and there you go. Now, if I go ahead and mention df, it's back to normal. And why? Because the dropping did not take place. Now, how do you let the dropping take place? It's by going here, Shift Tab, and you have this in place argument. And what does this in place do? It tells you that, do you want the effect to take place? Do you want the dropping to take place? If so, you have to set it to true. So in place is equal to true as such. Go ahead and hit Shift Enter, and the effect, let's check if the effect took place. Enter, and there you have it. So here the code has been executed, and here we have printed the data frame. As you can see, the second column is not there, so it is in place. This is what we mean by an in-place method. Okay, now this is useful when you just want to visualize before the code taking place. Okay, let's say I do not want to remove the column, I just want to visualize the column without the data frame, without this column. So you would want this to be false, or by default it is false. Okay, now that's it for operations. Let's go to the next section, which is data or file I/O, or input output. So here we will be discussing 3 basic formats. The first one is CSV files, or comma separated files, which you could create using any text editor or Excel. The second one is Excel or spreadsheets. And the third one is HTML, over the web. So let's start off by reading a CSV file. So the way you do this is by mentioning pd.read. And by the way, you have all those formats you could read from: CSV, Excel, which we will be discussing right now, HTML, JSON formats, databases such as SQL and SAS, and so on. So read CSV, and right here you should mention the path of your file. So ./ means the current directory. Hitting tab, I get the folders within my directory. I have data files. Hitting tab again, I get all the folders within data files. So let's read mcdonalds.csv. Hit Shift Enter, then print df, and this is my CSV file in a certain data frame, which means that I could format and modify my df to my own good using all the methods we previously discussed. So let's say after processing, I put it in another data frame, which is df2, and now I would want to write onto a new CSV file. So all you have to do is say df2.toCSV, and just mention where you want to save it. So let's say I want to save it in my current directory, not inside my data files, and I would say the name of my file. So let's say McDonald's output.csv. Shift enter, and there you have it. And if I go right here, here we have the file .csv, which I just created. Okay. Now this is how you work with CSV files. Let's say you want to read an Excel file. So pd.read Excel. Again, the path. And this time, I want to read a .xlsx or an Excel file. I have a sample right here. Let me read something else. Sample output. So this is something I created right here. So run. df looks like this. df is something I can play with. So let's say id is this. id, the second index is this. Let me change it to this. And I have a warning because I think I have a spreadsheet right. I think this folder is locked. That's why I cannot modify it. So forgive me if it's not modified. And let's say after modification, I wrote it to another df and I would like to write to a new file. So df2.toExcel, and we should mention the name of the file. So I would like to write it to my current directory, my Excel file that I just created, .xlsx, run, and there we have the file right here. Okay, now let's go to the next topic, which is reading from HTML or a website. So I have this website right here, which is my Google Scholar account. Okay, and right here I have some tables which may not be obvious. So as you can see, this list right here is a table in HTML. And if you're familiar with HTML code, which is not necessary for this lecture, I just want to show you that if I go ahead and inspect tables right here, so the table is this element right here, everything starting or containing the tag tr, right, or th, right? So this is a website that contains tables. So what does that mean in terms of pandas? So if I go here and I read the website as such, so df is, or let me call it out, is pd.read HTML, and I go ahead and copy paste this website link right here as it is and hit shift enter. So right now it's retrieving the data right there, out, and there you have it. This is the tables in the website. So what is the type of out? Type, it's a list. It's not a data frame yet. It's a list. So what is the length of this list? It's 2, because this website right here contains 2 tables. This is the first one right here that you can see this list. The second one is here, somewhere here. Okay? Now if a website does not contain any tables, it will return an empty list, or it will warn you or give you an error. Okay? So let's extract the first table, out 0, and as you can see, what is the type of out 0? It is a data frame. So this is out is a list of data frames. So out 0 is this table right here, and out 1 will be this list that you see right here. Okay? Now you can treat it as a data frame because it is a data frame, and you could work with it as you please. using the methods we previously discussed. Okay? Okay, now we're going to visualize our series and data frames using Pandas visualization toolbox. So we're going to plot a lot of fancy figures such as histograms and pie plots, even normal 2D plots, box plots, and area plots. Of course, there's many others, but those are the most, popular ones. So without further ado, let's get started with visualization. Let's first initialize a certain data frame. So data frame np.random.randn, for example, a normal distribution, or let us keep it simple as a uniform distribution, which is formed by, let's say 100 rows and 2 columns. So right here, index and columns, I will only label the columns as A and B. Now, as you can see, this is a big data frame. It consists of 100 rows. So if you just want to take an idea of how your data frame looks like, all you have to do is run df.head, and you will get only the first 5 elements if the length is greater than or equal to 5. The number of rows is greater than or equal to 5. Now, let's start by plotting a simple 2D plot of, let's say, the columns or the entries in column A. So all you have to do is call df column A dot plot as such. Run, we do not see it. So there's a command right here we should be running before, I think, which is matplotlib inline as such. So this allows us to view it in our Jupyter notebook. If you don't have matplotlib installed, all you have to do is, as we did in the beginning of this lecture, go ahead to terminal and type down the following: pip3 install matplotlib. Okay? If you're using Python, this is for Python 3+. If you're using Python 3 minus, then just run a pip install as such. Okay? So this is how A looks like, the columns in A. As you can see, they're plotted. We have 100 points as such. And the values are on the y-axis, whereas the index is on the x-axis, right? So in the plot, we have a lot of attributes or arguments we could set. For instance, we could say, let's say I want a line style as such. Line style, or ls, you could also write line style as such. It means draw the line as dashed, in a dashed format. Also put one dash as a straight line, continuous straight line. Also put a colon as such, dotted line. You could choose, no, this is a marker. So let's keep this for the marker. So yeah, this is how you could play around with line styles. You can also play around with color. So if you want it to be green as such, blue, black, red, this is how you can change the color of your plot. You can also set the marker. So what is a marker? It's put, because we have discrete values, so 100 values right here. Each value is marked by a certain marker. So here I chose the asterisk. You could choose other stuff like, say, a triangle as such. Or, I don't know, do they have diamonds here? Yes, D. Dot maybe, yeah. 1, and so on. So this is how you change the marker. You could change the marker size. So if you want the markers to be bigger, you can also control that. So it's the marker size. Let's increase it to 20. Here we go. Those look ugly, so let me just put in some, triangles. And as you can see, the figure is messy. Let's say you would want just to observe the values between 40 and 60. So you would like to open a window here between 40 and 60 and just observe, the variations over there. So you can do so using xlimit and just set the values 40, 60. There you have it, between 40 and 60. Okay. You can also change the marker color. Let's put yellow. I think it's the marker edge color. Yep. So marker edge color is the color on the edges. Okay. You've also got other stuff like, let's see. Yeah, so you've got another option which is marker color, face color. That's the filling. So let's say you'd want to fill it with a purple color. There you have it. You've got way more options you can play with and so on. So let's say you'd also like to limit your y, your y-axis between values from 0.2 to 0.8. You can do so by using, as we used xlim or xlimit, you can use y-limit as from 0.2, let's say, till 0.8, run. You could see the window along the y-axis. Okay, so that's it for a basic 2D plot. This is how you play around with pandas using 2D plots. So let's go to the next topic, to the next subtopic, which is plotting a histogram. So let's say using the same data, DFA, I would like to plot a histogram. All you have to do is call not hist plot.hist as such. So as you can see, you've got, the values right here. How many values occurred in this certain bin. Let's say you're interested in more bins. So all you have to do is set the number of bins, which is bins, is equal to, let's say you want 50 bins. There you have it, you have 50 bins. 10 bins, 5 bins, and 1 bin will leave you with only 1 bar, which is uninformative, right? So 20 bins. Can we change the color? Let's check. On the color red, here we have it. Can I do an X limit? Let's find out. 0.2 to 0.8. There you have it. So yeah, this is basically how you do a histogram. What else you might use? Let's say you want to, I don't know, plot another histogram. So let's say df2 is pd.dataframe, and let's just set the values random.rand, no, it's np.random.randn. So this is normally distributed, run, and df2. Let's see how it looks like. So they're indexed by numbers because we didn't mention the index labels. So df2, let's say the first column, hist, or plot hist. Will hist work, by the way? Let's check. Oh yeah, it does. If you want to plot it, so there's no difference whatsoever. There's only the grid, as you can see right here. Anyway, this is a normal distribution. Let's plot the other one. There you have it. And yeah, this is basically how you work with histograms. Let's say you want to plot a box plot, or before box plots, let's say you run df as such, df2 as such, and you run a hist or plot hist. You can see both histograms, and their column number or column label is a legend. So this is automatically done with pandas. Also, you can do so with the normal plot. So df2.plot as such, the 2D plot. And as you can see, you have two figures with labeled legend as such to discriminate the two curves. So this is something cool done by pandas. Let's go ahead and do df2.plot.boxplot or .box. And as you can see, the first column has this box plot, the other one has that box plot. Okay? You can also change the color maybe, red, yep, and so on. Let's go ahead and see how an area plot looks like. So df2.plot.area, and we have an error because, okay, so let me specify what is the error here. When stacked is true, each column must be either all positive or negative. Yeah, so also, so those values should be positive, I think. So this is a df which is all positive. So .plot.area. Okay, so when you want to plot an area curve, you should make sure that your values are all positive. So df contains all positive values, whereas df2 contains, a mixture of positive and negative values. So this is how you go ahead and plot an area plot. Okay. So yeah, this is basically how you work with plots on pandas. That's about it. This is all what you need to know about pandas. Those are the basics and a bit of the advanced aspects of pandas. If you want to go ahead and read more about the functionalities, all you have to do is visit the pandas website, the one I was opening in the beginning of the lecture, and I will share it in the description of this video. Or you can go ahead and do some smarter stuff like PD and hit tab. You can go ahead and read all about those functions right here. So let's say I'm interested in Excel file. All I have to do is type it down and then hit shift, hold shift, then hit tab. And as you can see, here's a description with all the inputs and outputs and everything it does. It's like a manual for this function. Okay, I hope that you enjoyed this video, and I'll be seeing you in future ones. Goodbye.